Hello and welcome to another Spastic Kangaroo tutorial. Today we're going to be going over a fairly detailed explanation of the fluid simulator. So let's get started. So what's the fluid simulator composed of? The fluid simulator is basically made up of a domain object and one or more fluid objects, controllers, inflows, outflows, and I'll explain what each of those do. So, every fluid simulator requires a domain object. So, we're going to create the domain object right now. So, we'll just take the default cube and make it line up with the grids, the grid floor, and we're going to add the fluid simulator. And select domain from the drop down, actually to drop up. Now, you're going to get a lot of panels with tons of options you can choose from. Right now, all we're going to worry about is the resolution. Okay, so the resolution is going to be the amount of detail in the fluid simulation, as its name implies. So let's set the final resolution to be 45 because I want to be able to bake things quickly. And for the preview, just turn the preview off by setting it to 0. That'll save some bake time. And we're going to viewport display. We're going to make it view the final display. So it's going to be viewing the resolution of 45, not the resolution of 1. And it's going to render it at 45 too. Now, let's go through each fluid object. First of all, we're going to add a cube. And everything has to stay inside of the domain. So let's add a cube, make it a fluid, and select fluid. That's all you have to do. And now, you'll have these options. Most of the time you don't need to worry about these unless you want an initial velocity, and we'll just give it an initial velocity along the x-axis at 0.1. So now if we hit bake, it'll bake the simulation, and the domain will turn into a fluid, and give it time, and it'll eventually splash down and fill up the original domain as much as it can. It's just going to be the fluid the same size as the cube. And once the fluid simulation is done, you can delete the original cube. But since it's simulating right now, let's just hide it. And it'll still simulate, right? So there you go. That's a basic fluid simulation. The time. What it does is it sets the time of the entire animation. Now right now, I didn't bake the entire thing. I just ended it right, let's say, here. And if we play the animation, it moves very slowly and not very realistically. And the reason is because the time is set at 4 seconds. This is in seconds, not frames. So the time is set at 4 seconds, but the length of our animation, view show seconds in the timeline, is 1 second long. So if we set this to 1 second and bake again, it will now be in real time. Let me pause the recording. And so now if we play back the animation, it will look much more realistic. I mean, obviously this computer can't keep up, so let me just add frame dropping. And if we play it back, it'll be a much more realistic speed. You can also set the speed of it in here, if you want slow motion. You can also click reverse fluid frames, and it will invert the animation, so it plays in reverse. And you can offset the time that it starts, so if, say, you had a river and you wanted it to be a fluid simulation, but you wanted it to have already simulated partly before the animation started, you can use the offset to set the starting frame, and now when you play back the animation, it has been... so it's already been partially simulated. And just leave this checkbox on. It's generate speed vectors, and you want that for motion blur. So if you wanted to have motion blur in your fluid simulation, keep that checked. Now we're going to move on to the viscosity. Viscosity is thickness of the fluid. And I've gone over this in my cream simulation, but I'll just quickly review. This is a preset. These are all presets if you wanted to use one of their presets. The base is the base viscosity. Exponent will put it to the negative. We'll put the base times 10 to the negative whatever exponent you put in here. Let me reset my offset. And there's fluid boundary, which is basically ways to edit the boundary itself. Edit the domain itself. So we can add slip. We can edit the friction. This is friction. That's the slip. So if we put it way up, it would be a lot stickier to the edges than it would if you put it all the way down. And then there's fluid particles. And these are for simulating tiny droplets that fly off. Now, in this animation, we can see these like large globs that fly off, but that's not really particles of water. And you can add that if you used particles. So let me say 5 and generate particles 1, and I'll bake this. Okay, so my simulation isn't really high enough resolution to be able to see too many particles, but we do have a few. We've got like one little guy right here, and a few extra small ones over here. And if you turn up the simulation resolution, it will be simulating a ton more particles. And I did have to turn up these particles midway bake and rebake it because they weren't high enough to generate any for, again, such a low resolution fluid simulation. Okay, I just realized that tracer particles are particles that fall behind the fluid, according to Tony Mullen's Bounce, Tumble, and Splash, which is a little bit outdated since it's using 2.49, but is still a good book. I'll have a link in the description. Tracer particles follow behind the simulation, so you actually don't need to set them if you want to generate these little particles. Okay. So now let's move on and talk about outflows. So I've quickly done another simulation, and now we're going to be showing you an outflow. Now an outflow is essentially a drain. That's all it does. It removes fluid from the scene. So all you have to do to make an outflow is to add a plane or cube or whatever, any type of mesh. And so let's make it a box so it gets rid of fluid faster. And we're going to set it to outflow in the fluid panel. Make sure the enable is checked, and don't really worry about that. So now if we bake it again, so now you see when we simulate it, the water gradually lowers. So that's outflows. They're not too complex to work with. Now let's talk about inflows. So we're going to set fluid, inflow, and we'll set inflow velocity. We'll make it go to the left a little bit. And I'll hit bake. Okay, so I simulated this and deleted the original fluid object so it wouldn't get in the way. And here's what it looks like. Like a stream of water. So let's go over one more fluid simulation type. Oh, actually 2 more. There are 2 more. There is the particle type, and I'll go over that one next, but this time we're going to be going over the control type. So first of all, let me give this a higher resolution so you can actually see what it does. So let's just give it a resolution of 100, and we're going to add a monkey and we're going to set this fluid type to a control object, and this one has more options than any other fluid type other than the domain object. But what does it do? Well, it will pull the water in its direction like a magnet. If I simulate this and make sure you've got a lot of strength in it, well, that's maximum strength right there. And I don't think you really have to worry about that as much. And we're going to set the radius to a smaller number, so it is closer to the original control object. And now if I hit bake, we'll see what happens. Okay, so I didn't simulate the entire animation, but I did simulate a few frames just so you could see what it looks like. So, let me just hide the original monkey, hide the original cube, and now if we go by frame by frame, you can already see on frame 1 Susanna is starting to rise out of the water, and as we go each frame on, it pulls more and more water up. Like right here around the ear, pulls up a bit more of water, and it eventually takes more of a shape that looks like a monkey. So thank you for watching this spastic kangaroo tutorial. If you have any requests for future tutorials, please post it in the comments below. I'll be happy to do them. And make sure to subscribe so you don't miss any art and programming tutorials. Thank you for watching, and we'll see you all next time.